Section 6.6 is titled Solving Systems of Linear Inequalities. So first we want to discuss how do we actually solve a system of inequalities. We're going to graph each inequality separately on the same graph. And you want to make sure that you shade lightly because the solution to the system is where the shading overlaps. We also still need to remember how to determine what style of line we want. It's a solid line if we're talking about an inequality that's less than or equal to or greater than or equal to, but it's a dotted line if it's just less than or greater than. So let's solve the system. Essentially, we're just going to graph both of these lines on the same graph. So I'll do the first one in red. We have y is greater than or equal to negative x plus 2. So we're going to start at positive 2. My slope is negative 1 over 1. So I want to make sure I'm going in the negative direction. And it's greater than or equal to, which means I'll have a solid line. And I want to pick a test point, so I'm going to pick 0, 0. And I get 0 is greater than or equal to 0 plus 2, or 0 is greater than or equal to 2. That's not true, so we want to shade above the line. And notice today I'm just going to use lines like this, because this isn't exactly my answer just yet. Next line I'll do in blue. Y is less than negative 1/2 x plus 4, so we're starting at positive 4. You want to shade lightly because you want to still be able to see behind the graph in order to plot the other points. My slope is a negative 1/2, so down 1 over 2 in the negative direction. I'm also going up into the left 2. And this is just less than, so this is a dotted line. And I'm going to pick another test point. I'm going to pick 0, 0 again. So we get 0 is less than 0 plus 4, or 0 is less than 4. This is true, so I'm going to shade below. But here's where you have to be able to kind of ignore the red line, because we're shading below the blue line. So you're going to actually be drawing on top of the red line, but we're shading below the blue. Now our answer is where the shading overlaps. And this, once you've found that area, I'd like you to darken that in. So the shading overlaps here in between these two lines, just here on the right side of where they intersect. So there's the solution to the system of linear inequalities. It's the shaded area that's overlapped when graphing the two inequalities, which means that any ordered pair in that shaded region can plug into the inequality and solve the inequality, both of them. Let's look at another example. We have y is less than x plus 3, so I'll do that line in red. Start at positive 3. Our slope is a positive 1, and it's less than, so we want a dotted line. And again, you want to make sure that you're graphing these lines all the way across the graph. I'm going to pick a test point, 0, 0. So when I plug in 0 for x and y, I get 0 is less than 3. That is true. So I'm going to shade below the line where 0, 0 is. I'll do the second line in blue. We have negative 2x minus 4y is greater than or equal to 0. I'm going to use the intercepts here since this inequality is in standard form. So if I cover up the x, or excuse me, I'll cover up the y, I'll start with the y. I get negative 2x is greater than or equal to 0, so I divide by negative 2, and I get an x-intercept of 0. But if I do that same thing for y, to get my y-intercept, I cover up the x term, or I plug a 0 in for it and it's going to disappear, I also get 0. We talked before that when you get 0 for both intercepts, you actually do need to pick a second point or turn around then and solve the equation so that you can figure out what the slope is, solve it for y, or solve the inequality for y. I'm just going to pick another point. I'm going to plug in a 10 for x. So all the way down here. Hopefully I fit on the graph. So if I plug in a 10, negative 2 times 10 minus 4y is greater than or equal to 0. Negative 20 minus 4y greater than or equal to 0. I'm just trying to get the y value. Add 20 to both sides. Negative 4y greater than or equal to 20. Divide by negative 4. And I get that y, and I should flip my symbol here, is less than or equal to, what do I get, negative 5. So my ordered pair is 10, negative 5. So 10, 1, 2, here. Remember, whenever your intercepts are both 0, you have to find another point. You can either solve the inequality for y to figure out what slope is, or you can just plug in any x value or y value, solve for the opposite variable. This is a greater than or equal to, so it's going to be a solid line. Now if I pick a test point, I'm going to pick 0, 0. I get 0 plus 0 is greater than or equal to 0. And be careful here. Oh, actually, I don't want to pick 0, 0. I don't want to pick 0, 0 because my line goes right through it. That's not going to do me any good. So I'm going to pick, I'll pick something down here. Let's pick 0, negative 3. So I'm picking this as my test point. So if I plug in a 0 for x and a negative 3 for y, I need to check and see if this is true. So I get 0 plus 12 greater than or equal to 0. 12 is greater than or equal to 0. That's true. So I want to be shading down here. Remember, it's everything below the blue line, so you're kind of ignoring that red line. But our answer is where the shading overlapped. So you can see that's here in this section where the red and blue intersect. And it's kind of cut off here on the right and the top by the blue line, but it's cut off on the left by the red line. Number 3, we have y is less than 5x. This is an easy one to graph. Remember 5x plus 0, so our y-intercept is 0, up 5 over 1, and down 5 to the left 1. This should be a dotted line. If I pick a test point, if I pick 0, 0, I get 0 is less than 0. Oh, again, I don't want to pick 0, 0. I need to be looking at my line first. My line goes through 0, 0, so I don't want to pick that. So let's pick something over here. Let's pick 6, 0. So if I plug a 0 in for y and a 6 in for x, I get 0 is less than 30. That is true. So we're shading to the right of this line or below the line. You can kind of see the slant we're below. And then we have y is greater than or equal to 0. Remember, this line has 0 slope since there's no x, which means it's a horizontal line where y equals 0, which is at the origin, which means that this is the x-axis. Horizontal line that goes through y equals 0, that's the x-axis. And now we're talking about all the values that are greater than 0. All the y values greater than 0, so that's everything above that line. You could pick a test point. Remember, though, there's no x to plug in, so your test point, you're just plugging in whatever y value you get. So if I pick something above the line, let's say I pick 0, 5, I'd plug 5 in for y, and I get 5 is greater than or equal to 0. That is true, so I do shade above. But again, remember, your answer is where the shading overlaps, and so that's here in this section. And you want to make sure it's obvious to me where the shading overlaps. If you'd like to pause the video here and try this one on your own now that we've done some examples together, graph each inequality and then look for where the shading overlaps. So we have y is less than or equal to x minus 3, so we're starting down at negative 3 on the y-axis. I'm going up 1 and over 1 in the positive direction. I want a positive slope. This is going to be a solid line. Since it's y is less than or equal to. And if I pick a test point, if I pick 0, 0, now I can pick 0, 0, my line doesn't go through it. I get 0 is less than or equal to 0 minus 3, or 0 is less than or equal to negative 3. That is not true. So we don't want to shade up here where 0, 0 is, we want to shade down below. Second inequality, we have y is greater than x plus 2. So we're up at positive 2. Again, we have slope that's positive 1 over 1. And this is just a greater than symbol for this inequality. So our line is going to be dotted. I can pick 0, 0 as a test point because my line does not go through 0, 0. So I get 0 is greater than 2. That is not true. So I don't want to shade down below the line where 0, 0 is. I want to shade up above. And our answer is where the shading overlaps. And hopefully here you can recognize that the shading does not overlap anywhere. So we have no solution. Or no solutions. That means that there is no ordered pair that you could plug into both inequalities to solve them. And you may have recognized that these lines are parallel. Just because they're parallel doesn't mean that it's no solution. Had this symbol been flipped the other way, we would have shaded below the blue line, and then everything down here in this red section would have had red and blue in it. So just because they're parallel doesn't mean it's no solution. But it did mean that in this case because we shaded below the red line, above the blue line, and we had no shading overlap. Now let's go the other way. Let's look at a system that's graphed and write it out. So let's write the linear inequalities. Doesn't matter which line you start with. I'm going to go ahead and start with this vertical line because I know that this is an x line. X equals some number, but it's an inequality. So based on shading, we're going to be greater than, less than, greater than or equal to, or less than or equal to. It is a solid line, and it's going through 2 on the x-axis. So I know it's x, and it's either greater than or equal to, or less than or equal to 2. It is shading here. If we look at the shading is over to the right. It's everything greater than 2. It's 3, 4, 5, 6, 7, 8, 9, 10, and so on. So that means its x is greater than 2. Remember, you could have plugged in a test point. We don't have a y value here, so when you plug in the test point, you're just plugging in the x test point that you pick. So let's say we picked 7, 0, and we weren't sure about the symbol. Let's say we didn't know this. You plug a 7 here and a 2 here. We want it to be true. 7 is greater than 2. Therefore, its x is greater than 2. And excuse me, it's greater than or equal to, since we have a solid line. The next inequality is going to be in slope-intercept form. I know there's going to be a symbol in the middle. There's going to be some number in front of the x for slope, and it's going to be a plus 3 because it goes through 3 on the y-axis. I just have to figure out what the slope is. And it looks like it's down 1 over 1, down 1 over 1, down 1 over 1, which is a negative 1 slope, or just negative x. The symbol here is either going to be greater than or equal to, or excuse me, it's either going to be greater than or less than, because it's a dotted line. So let's pick an ordered pair. Let's pick 0, 0. So if we have 0, and then 0 plus 3, Well, 0 is less than 3. Remember, we want this to be true since that's where we shaded, was where 0, 0 was. So that means that this symbol is less than, and here is your system. X is greater than or equal to 2. That's the vertical line with the purple shading. And we have y is less than negative x plus 3. That's the dotted line with the yellow shading, and then the solution here would be this red where the yellow and purple overlap. And in class we'll work on worksheet 6.6.